watch our YouTube live streaming. Please make sure that you also keep a watch at your WhatsApp groups where we'll be posting the links. Hi, good afternoon, good evening. Okay, so we'll begin in next 2 minutes or a minute. We're just starting now. Please make sure that you ask all of your team members to join the call, join the Zoom call, or if they were not able to join this meeting, please ask them to switch to the YouTube live. So let's begin. Hi everyone, welcome. I am Tanuja, and I hope you all remember that I was your host for the first orientation session. And I hope all of you are, you know, excited to attend this first masterclass where we have your expert with us. So before I introduce Karthik, our today's expert, to you, I'd like to make a few announcements. So I hope you all remember that the last date for the learning plan.
Tanuja, I'm so sorry to stop you right now. Just the students are just joining in, so there are only around 500 students inside. They're just coming in from the waiting room. So let's
Oh,
just give another 2 minutes because around 400 plus students are still in the waiting room. Yeah,
okay,
just
sure.
another
No
two
worries.
minutes. Yeah.
No worries. Do
Okay.
let me know. Yeah.
Yes. Thank you.
Okay, so we'll wait for others to join in. Till then, I hope you all are excited for this masterclass and for this whole journey. Hope you're all able to access the platform and finding it feasible to, do the courses. Okay, let's do a, React panel poll. How many of you are excited? Show me a thumbs up or maybe a celebratory this thing. How many of you are excited for today's masterclass? I hope you all know that it's a live class that you'll be interacting with a subject matter expert today. Wow, so many thumbs up. Good to see that all of you are so enthusiastic. Okay, we'll be beginning in 2 minutes. We're just waiting for most of the participants to join us. And the ones who could not join the Zoom call, please, if your friends are facing this problem, please let them know that we have hit the limit for Zoom. They can switch to the YouTube live. Okay. My friend didn't get mail. Okay. So if your friend hasn't received the mail for any reason, please make sure that you share this Zoom meetings link or the YouTube live link. Both the links, please share it with them. And if they are in the WhatsApp group, I'm sure they have received the links. And I think we can start now.
Yes, Tanuja, we can start. Just
Okay,
recording the meeting.
sure, sure. So yes, this class is live on YouTube as well because we have hit the maximum number of participant limit here on Zoom. So if your friends are not able to join, let them know that they can join it on YouTube. Okay, so let's begin this session. Thank you, Anne. Okay, so a very warm welcome to everyone to the first masterclass, DA Masterclass, Decoding Data. So we have today with us Karthik Huda, your subject matter expert, who will be guiding you throughout this process, through this journey on this topic of decoding data. So it's time to welcome him. Before I do that, I'd like to make a quick announcement. Just a reminder that your learning plan completion certificate should be submitted by 14th July. I repeat, 14th July is the last date for submission of your LP completion certificate. And please don't panic, don't worry about Where do we have to submit? How do we submit? We will be sharing an LMS link shortly with you all, where your team leader will be submitting your all of the team participants learning plan certificates. Okay, so the link will be provided to you in some time. Rest, you know that you have to complete the learning plan before 14th, right? That's about it. So let's begin this session. I would like to welcome Karthik. So before we welcome him, let me give you a very brief introduction about him. Karthik, I'll just share the PPT that Karthik has shared with us for his introduction. Just a second. Okay, yeah. So Karthik is somebody who enjoys computer science statistics, and he specializes in data analysis, SQL, Excel, Power BI, Tableau, and Python for analytics. Karthik has delivered several sessions across both academic and corporate settings, guiding learners through practical applications of analytical tools and techniques. And when he's not playing around with numbers, you'll find him either playing cricket or enjoy music. So let's welcome Karthik. Karthik, the stage is yours.
Thank you. Thank you very much, Tanuja.
You're
Thank you for
welcome.
the great introduction. So, hello everyone. Welcome to the first masterclass for decoding data, IBM SkillsBuild for Adult Learners 2025. I really hope you're all excited to be here, and I also hope that you will have a great learning as well as fun experience throughout this session. So, this first masterclass today, it is about introduction to data analytics. So, before we move ahead, I really hope that you guys are, even if you are not well aware of what data analytics is, it's need not worry. You will learn from basics everything. And if you are already aware, even then you will learn a lot of new things in here. So without any further ado, let's start with basic understanding of what data analysis is. So, in very simple definitions, the systematic process of either inspecting, cleaning, transforming, or modeling data, although these are the only four key terms that I have used here, but data analytics also comprises of many more processes, but the basic processes are these, and this combines to make up data analytics. So, the goal with any process of data analysis is to extract useful insights that can eventually help us making our decisions. So usually you would see any raw data. Let's say you download the census table from the census website, let's say 2011 census, you will find millions of rows and maybe hundreds of columns in that. And you would see that raw data doesn't really make a lot of sense. Even if it does make a lot of sense, it is very hard to understand or navigate. So the goal is from that raw data, extract meaningful insights that can help us make our decisions in the future. It could be data for sales, it could be customer data, it could be feedback data, or it could be government data. It data analytics covers almost every field that is out there. And you guys might already be aware that today our world generates 2.5, I think, a quintillion gigabytes of data every day, and that is 18 zeros. So data is everywhere, and data analytics is a key skill that is needed for you to have a bright future. Data analytics also helps us uncover patterns that are hidden within raw data that might not be really visible without the applications of data analysis. It empowers smarter, faster, and more effective decisions. And that happens because our data is rooted in facts, or are the decisions that we make, they are rooted in the data that is in facts, because we are not just making bluffs or making guesses, but rather making effective decisions through the process of data analytics. And it is applicable in almost every field out there. Although I have mentioned only three, that is retail, healthcare, and social media. But data is everywhere, and so data analytics is required in almost every field out there. And very important, majority of data analysis tools, they are beginner friendly. Most of the activities are beginner friendly, and as you learn more, you develop more, you can be able to learn the advanced tools as well. So before we get into more technical or theoretical stuff, I'm sure you guys have previously maybe worked with data or even studied data analytics. So you guys have maybe used a few tools that are very helpful or beneficial for data analytics. So before we get into technical stuff, let's test out. This is a very simple and easy activity we'll do, a very simple quiz. Let's see how many of you can identify the tools that are nowadays widely used in the world of data analytics. So let's start with the first one. It's quite easy. So let me know how many of you can recognize what this is. Okay. So that was on me. I gave you something very easy. I am getting a lot of this. This you are all correct. This is Excel or Microsoft Excel. So Microsoft Excel is a spreadsheet program by, of course, Microsoft. And although on the surface it looks like a very basic spreadsheet program, but under the hood it is a dynamic platform for analyzing, sorting, and organizing your data. All right, so this was easy one. Let's see how many of you two can find out the next one. All right, let's get your answers for this. Oh, even you guys are quite aware. All right, so many people are guessing Tableau. I see one guess of SQL. Okay, so yes. Okay, who said Siri? Somebody is saying this is Siri. And yeah, majority of answers are Tableau. So yeah, you will all be correct. This is Tableau. All right. Let's move on. One more. Okay, so this is another easy one. Quite popular. How many of you can guess that? Power BI, Power BI. Yeah, somebody said Instagram. Yeah, they do have similar looking uh, logos with different colors, but nice. Okay, yeah, so this is the Power BI. So let's move on from this as well. Okay, what is this? Fire in your guesses. Yes, you will be correct. I think Abhijit loves SQL. He has guessed SQL for almost all the answers. Yes, this is Python. Most of you, majority of you are correct. Lisa Das says that Tableau is so difficult. No, Lisa Das, I would like to differ. It is a very great visualization tool. Okay, moving on. So this might be a bit complex one. How many of you can guess this? Okay, you guys are guessing SQL, but SQL is a programming language that stands for structured query language. Yeah, only Rohit is correct. Rohit has guessed the name of the tool. It is MySQL. So SQL is a language, stands for structured query language, but this tool is called MySQL. It is a relational database management system. All right, okay. So that was it for our initial activity. Now let's get into some technical stuff. So let's start with why data analysis matters. First and foremost, obviously, it helps us transform raw, unstructured data into meaningful insights. From even the data that looks too messy or almost impossible to understand, applying the right data analysis techniques and tools can help us transform that into something much more meaningful and increase our understanding, make our process much more efficient. Data analysis also enables fast, confident, and intelligent decision making. As I previously said, you will not be making bluffs or guesses. Through data analysis, you'll be making decisions that are rooted in your data. And so those decisions will be based on facts. So it prevents valuable data from being underutilized or overwhelmed. So at times, when you see a lot of data, as I previously mentioned, maybe millions of rows and thousands of columns, there's a possibility without using the right tools and techniques, you might skip upon or even accidentally miss a great amount of data that can help you provide much more meaningful insights. Or sometimes that large set of data can also become overwhelming, too much for you to take care of. But with the right tools, right techniques, you can make all that process very easy to do, very efficient, and utilize every single part of your data. And through all those processes, in today's world, data analytics is enhancing industries almost everywhere across the world, be it business, healthcare, science, or government. It helps you sup- support trend identification, forecasting, and also operational efficiency. Because it's through data, you are able to make predictions. And these predictions are not just blindly said words, but they're rooted in real facts. And forecasting, be it a basic weather forecasting or forecasting what stock might go up or might go down, or what product is going to behave, what product is going to sell more, or maybe about health as well. You guys must have heard people are nowadays using data to identify who might have cancer, what cell might turn cancerous in the future. Then it also provides evidence-based guidance. As I said, no bluffs, only every strategic decision based on evidence and facts. Now, these are the three main goals of data analysis. Although within these three, we will see many more subcategories, but this is the surface level, the main highlights. Now, we have to make sense of data, uncover what are the patterns hidden, and based on what we have found out, we provide actionable insights. That is what actions to be taken, should be taken in the future, or not just in the future, what can be done today. Now, these are some of the everyday applications of data analysis, not too professional. But as I previously mentioned, although I mentioned only three on your screen, but the applications of data analysis are countless in today's world. Since we live in a digital world, data is everywhere, 2.6 quintillion gigabytes every day. So if you look at in more detail for these three, in retail, you can optimize your sales strategies. What product should be sold on what day or in what month? What product is not selling so that you can minimize your waste? Or what product might sell, maybe stock extra of that in your inventory. And based on customer demand, you make a strategic decision. In healthcare, through the enormous amount of data that we can use and analyze. Now, imagine you are any doctor or maybe in medical professional, even as a regular person. Let's say you receive your medical records and you try to read it through, maybe your 10 pages or 12 pages. And let's say even the most qualified surgeon or doctor, maybe he or she goes through a list of, say, 1,000 patients a day, and still, due to many different circumstances, you human might miss something or miss a data here or there, and maybe not able to recognize what diagnosis might be correct. But with data, you can analyze millions or billions of records in a very short span of time, and it increases the accuracy and increases the effectiveness of the treatment as well by analyzing patient records that are data driven. For social media, if you can personalize your content feeds, I think this is something that you all must be most aware of, whether you are on Instagram or maybe on YouTube or Netflix or any other platform. You will see that as you are watching more and more, the platform starts to understand what your behavior is like or what your preferences are like. And based on that, it analyzes behavior patterns and hence is able to increase user engagement. Now, only these three, but the applications are endless. Now, these are some of the key activities in data analysis. First and foremost, of course, we start with collecting the data. If we don't have data, we cannot really perform data analysis. Then we move on to cleaning that data because the data that you collect might not be accurate. There might be errors or missing values or inconsistent values. So cleaning and transforming data comes up as the second step. Then we try to explore that data, actually learn what that data is. We maybe summarize it or visualize it to understand what the structure is, what the hidden patterns are, or what are the key features of that data. Then, after we have explored it, we try to apply our methods. Maybe for statistics, or maybe for finances, or maybe for tech, we apply our methods or models and visualization to detect the patterns and relationships between the data. And finally, we interpret the results. That is, we translate our data into findings that based on which we can provide recommendation. That is what should be done or what has happened, what the data is trying to tell us. That is what happens in the last stage. Now, here comes Lionel Messi. So, Lionel Messi is one of the greatest footballer ever, and he's my favorite football player as well. Now, I don't know if you guys watch or play football. I'm sure many of you also love Messi. I do. Now, you all might be thinking, why all of a sudden we are talking about football in the middle of a data analytics session? So, we are now going to look at a brief example of data can be used even in places where you might consider data to be least likely used or data analytics tool to be least likely used. So let's start with a small example. So let's say you are an analyst for one of your favorite football teams. It could be anything, Arsenal, Real Madrid, Barcelona, or even Indian teams like I support Bangalore FC. So let's say you receive this kind of data. You have name of the players like Varun, Arjun, Rohan, etc. Then the positions from which they took shots, then the method from how they took the shot, be it by a header, by their left foot, or by their right foot. And then what was the outcome? Whether the shot taken was goal was scored, it went off target, or was it on target? Now, see, looking at this data, how do you make people understand what does position 95 and position Y95, position X21 mean? And plus, you have tens of thousands of rows of that data because in a season, there might be 100 games. And within 100 games, more maybe 100,000 shots were taken. Now, imagine taking those 100,000 rows of data and going up to player or coaches and trying to tell them that this is what has happened, that Varun took a shot from 19.5 meters from the left and 21 meters from the top. He used his head to score the goal. Now, how inefficient and complicated this might be. But if we use a very basic data visualization tool that we call the scatter plot, then this is what the scatter plot will look like. Now, you will see that I haven't even formatted it at all. I haven't made the pitch, made the background, or made the important lines. But just by plotting a scatter plot that is very mathematical and technical, you will see that now this becomes much more easy. Even if you are a genius data analyst who can read data like a machine, this becomes so much more easier for us to understand as human beings. As these are the points that you see from where the shots were taken. Now you see, now we know that all these are the points where the shot was taken from. Now we don't know whether this shot was the goal was scored or it went on target or off target. But what we can do, We can filter our data. That is another important tool of data analytics, that is filtering your data based on your preferred criteria. If I filter my data and only choose those where the goal was scored, and again plot a scatter plot, then this is what it will look like. Now imagine you being part of a team. How you can help players is you can tell them that these are your strong points. Strategize your game or play your game in a way that whenever you're playing, try to take shots from these places, because the likelihood of that going in or that goal being scored is quite high. Or maybe imagine you are the analyst for the opposition. Then maybe you can guide your team or teach your team into learning that these are the strong points of the opponent. Strengthen your defense in these areas. Strengthen, maybe put more players over there. Or strategize your game in a way that these areas are heavily guarded. Now, you see, even in goal scored, we now have seen a very surface level visualization or analysis. Within goal scored, what we can do rather than these multiple points on your scatter plot, we can find the one strongest point. So what we can do, very simple, we will just find the average of all the y-axis coordinates and all the x-axis coordinates, and see, this will give us this one point. Now see, even further you can say that although there are many points from which the goals were scored, but the one point where the team stands out or is the strongest point, then it is this point. So it is very important whenever the team, for your home team, you can say strategize, play in a way that you take your shot from this point, and same for the opposition, you can say that guard this point the most. Now we have all talked about what the strong point is. Now let's see what we can do. These are all the shots off target. I again filtered my data, selected all that was off target. Now, as a strategist or as a decision maker, you can guide your team to tell them that these are your weak points. Either play in a way that you do not take shots from here, or practice more from these points. So if you have a long duration, over the long duration, practice taking shots from these points. But in the short term games that are very close, play in a way that you do not take shots from there. And you can again find an average with this and find what the weakest point is. Going forward, you see, from all the surface level analysis, you can dig down as much as you want. I applied more filters, did some more calculations. So, and what I did was, I did not just take randomly goals scored or goals missed or average. I filtered it down to just one player and one method of scoring. So I filtered it down to one name, that is Vikram, took his coordinates, and I only took shots where the method of scoring was using his right foot, and the outcome was goal. Now, what we can suggest to Vikram, that these are your strongest points, but these are not just your strongest points by any method. From these points, it is very important that if you are on this position on the field and you take a shot, make sure you are using your right foot, or practice taking shots from right foot from these positions, as that is your strength. You can do the same with missing goals or left foot header. But see, you will understand through this example that data analysis can be surface level as you need, and you can dig as deep as you want if you know the right tools and techniques. So that was a good example to look at. Now let's see what are the different types of data. So on the surface level, there are mainly two types, and they are called qualitative and quantitative. So qualitative data is more descriptive and categorical data, that is more text-based data or alphabetical data. But when it comes to quantitative data, it is more measurable, more based in numbers. The data is numerical. We can apply mathematical formulas or functions and calculate them. Let's look at these two in a bit more detail, starting with quantitative data. So the definition is quite easy. the data that can be measured, can be calculated, is mostly based in numbers and quantities. The example can be test scores, product prices, the number of social media followers, and the temperature on different days or different months. Then within the quantitative data type, we have two more types. And those two types are called discrete and continuous. So continuous data is data that is mostly in range, and discrete where the numbers are hard coded and it is not in range. So to give you an example, you can store the same type of quantitative data as discrete data and continuous data. Let's say you take all of the students in your class and take their average test scores. Now you can either have, let's say, you in an Excel sheet where you have, let's say, 100 students, and in the cell next to each name or each roll number, you can give their marks like 67, 78, 74, 85, 95, and so on. So that will be discrete data. But how you can change the same data into continuous? What you can do, you make ranges starting with, let's say, 40 to 50, then 50 to 60, 60 to 70, all the way up to 100. And then what you do, rather than giving individual record to each name, what you can do, next to 40 to 50, you write 12. Then 50 to 60, you write 17. So in continuous data, data is in range, and you see how many people or how many data points, to be more precise, is in that range. And discrete data tells you straightforward information what the data is. So discrete data is quite helpful for analyzing and storing smaller size data, and continuous data works quite well with large data sets where we can sort it into range or sort it into category. I'm sorry, category would not be the right word to use. Sort it in a range and then perform operations with it. Now that was about quantitative data. Now let's look at qualitative data. So starting with the definition, as we already seen, it is descriptive data. It describes what the data is like. It is mostly text based or alphabetical based. It describes the qualities and characteristics. So the example could be product review rating. Like product review rating, although sometimes it can also be number based, like out of 5 what it is, or out of 10 what it is. But mostly product review is like, I liked it, I did not like it. I liked most of it, but some part of it was wrong. So a lot of product review rating is alphabetical or text based. The same goes with gender, and the same goes with colors, be it car color or any other color. Now, let's say few of you come together and let's say you start a company. You are selling shoes, maybe. Now, customer feedback is quite important. It is not necessary the customer give you straightforward feedback in what the rating is out of 5. If they like it, maybe they will praise you. If they don't, maybe they will abuse you. But going through all that data is also very important, as that helps you build a better product and learn more. Now, within the qualitative data types, you have two more types of data. They are nominal and ordinal. Now, nominal data is all. Now, if within the example, if you see gender and car color, actually not gender as well, car color or any types of color, it can be classified as nominal data. And why is that? Within the qualitative data types, nominal data is that is no particular order or no particular structure. Let's say a collection of all the names of the colors or the collection of names of people. But within the qualitative data type, you want to call it ordinal, it will still be text-based data, but still have a structure. So let's say you give out a form asking for a review, and rather than giving an open text field, just write down whatever you want, you give them 5 options, and you might have already seen it, like very satisfied, satisfied, not satisfied, very unsatisfied, or extremely unsatisfied. So you see, although the data is text-based or alphabetical, but still it holds a structure very similar to numerical manner, but still not quantitative. So that is the difference between nominal and ordinal data. All right, now we have time for it's time for another activity. Now, what I have done is I have categorized a few types of data on your screen, and your job is to categorize them into whether you think that is quantitative data or qualitative data. All right. So I hope you guys are ready. Let's begin. So let's say you have this type of data. You have a list of all the movie genres like action, comedy, drama, horror, etc. So what do you guys think this will be classified as? Is it qualitative or quantitative? Now let's go through your responses. Qualitative, qualitative. All right. So most of you are saying qualitative. Is there anybody with any other answer? Qualitative, qualitative. So yes, some Raghav said Ronaldo better. All right, Raghav, but Messi is better. He has 8 Ballon d'Ors, and a World Cup. But nice. I like Ronaldo too. So qualitative, qualitative. So almost. Oh, good job. What was that? Somebody said nominal. I'm really sorry I missed your chat. But that is good that you categorize it further into nominal data. That is good job. But yeah, most of you, again, somebody named Thanos is saying Sui and wants to say Ronaldo is better. Okay, okay. So let's move on. So yes, you are all correct. So Devajati said that King Kohli is better. Good. Okay. So you guys are all correct. This is qualitative data. Let's move on to the next question. So steps taken, maybe on your smartwatch or smartphone. Let's say you're tracking down for your fitness journey. How many steps you're taking every day? Be it 10,000, 2,000, 1,200, and so on. Quantitative, quant. Yes, majority of the answers are quantitative. Okay, so again, Anshul Agarwal has again said, Bhavya also said that this is the discrete, quantitative and discrete. So Ria also said, good job, guys. This is quantitative and discrete data. So yes, most of you are correct. This is discrete quantitative data. Krishnam Verma says that he did not understand the difference between nominal and ordinal. So Krishnam, nominal is generally uh, descriptive or qualitative data where there is no particular order. It could be a set of names, set of colors, or just maybe a list of YouTube comments, list of Instagram comments on your photo, where there is no particular order to it. But when that same text-based data or qualitative alphabetical data is changed to in an order, for example, the review being very satisfied, satisfied, not satisfied, unsatisfied to very unsatisfied, where even the qualitative data has a structure or an order, that is what that is ordinal data is. So without structure or without order, it is, remember that we can remember the word order. Ordinal data is order, but still qualitative, and uh, nominal data doesn't have order. Okay, so Utkarsh says that he walks 5,000 steps every day. Somebody, so you guys are now competing. Somebody else says he walks 10,000. Kapil said Sunil Shetri is the best. Okay, so any more opinions of yours? All right. Let's move on to the next one. Okay, so languages. What is your guess for this? If your language is in such Japanese, Spanish, Bengali, English, Arabic, what is your opinion for this? Qualitative, qualitative. Prateek Singh said that Tanuja is best. Tanuja, I hope you are hearing this. You are better than everybody else. Nominal, nominal, qualitative, nominal. Yes. So as most of you are correct, this is nominal qualitative data. Yes, so you are all correct. Still, I'm getting more responses. All right, let's close this and move on to some more theoretical part. Okay, now let's learn about data sources. So data sources are also primarily or majorly of two types, that is primary and secondary data. So starting by understanding primary data, data that is collected directly by you, and secondary, collected by others but reused by you or by someone else. To give you an example, let's say you and a group of your friends, you are doing a research on how climate change is affecting the nature in Uttarakhand. Let's specify it to a bit more. Let's say in the Chamoli district of Uttarakhand, and you guys want to find out. Now, there are two ways you can do this. You can either visit Chamoli in Uttarakhand yourself, talk to the local people over there, record that what the temperature is like on different days. Well, you can find out what the river water level is like, or what maybe if you go in certain weather, what the snow is like or rain is like. You collect it first time yourself. You conduct surveys among people, interview individual or group of people, and based on your own observation, the data that you will collect will be called primary data. So primary data is also in a sense original data that hasn't been. Now there's a possibility other people have also collected same data, because it's not that if two or more groups visit Uttarakhand, something will change. But the data collected directly by you will be primary data. And secondary data is like you, rather than visiting Uttarakhand yourself, you Google for government reports or weather articles, other research articles. Maybe a group has performed a research on a similar topic before you, and you use their data, and with maybe within your own research, within your own data analysis, you use that data to make sense or do your perform your analysis. Now moving on from the data sources, now we learn about the data formats. So data formats are mainly of three types. They are, as you see on your screen, structured, unstructured, and semi-structured. So these three words are quite easy to understand. As the words describe, the structured data is well organized, maybe into rows and columns, and it is quite easy to analyze. Let's say the record of all the students in in your college. It will most likely be organized, well organized, like your roll number, your name, your email, your maybe test scores, and other detailed information are organized into well organized columns and rows, and you can very easily analyze that. Then we move on to unstructured data. So I have given you an example before. Let's say you start a shoe company. The reviews that you receive, maybe on your website or maybe on a form that you have circulated. Now that kind of data that is has absolutely no relation to each other, that can be unstructured. Or maybe let's say you make a YouTube video, then all the comments that are there, they could be in same language or different language, and maybe somebody has complained with the background music that you have, somebody has complained with the editing that you have done, or maybe some complaint with something you have said or the type of content that you have made. And also let's say on your social media, a collection of all your images and videos. So that kind of data which has no structure and has no relation to each other, that is what we call unstructured data. And semi-structured, just like the word says, a mixture of both unstructured and structured data is semi-structured data, is mostly file types like JSON and XML. But to give an example, if you imagine your email inbox, if you look on the left of your screen, you'll see a menu that will have maybe sent, received, primary, social media, then spam. starred, all the see there is a structure on your left hand menu where your mails have been sorted and organized. But when you in the same page, if you go to the right of your screen or mostly to the center of your screen, you will see numerous number of emails that have come just from everywhere. There is no order to them, no structure to them. So that is a very good example. Another example would be, let's say you are on Netflix, and on Netflix you would see, if you just open the search bar of Netflix, before you search anything or even type one or two letters or word, you will see on the bottom of your screen numerous numbers of unrelated, unstructured movies, shows, different genres, different language. Everything will appear. But on the same Netflix page, on the left, you'll again find the menu where the shows are maybe the content is sorted into movies, TV shows, and maybe documentaries, or based on languages, based on genres, based on runtime. All that is sorted. So that those two are kind of good examples of what semi-structured data is. Then moving on to modern data sources. Now, see, I previously talked about uh, when I talked about your research in Uttarakhand, in Chamoli district. Now, see, we talked about primary data collection and secondary data collection. So, the digital world that we live in nowadays, we have satellites, we have connectivity almost everywhere, we have cloud computing. So, a lot of time, what happens is due to such digital age that we live in, a lot of websites, a lot of IoT devices, mobile apps, social media, APIs, and sensors, we are able to gather very accurate information through those devices. Also, although they might not be able to give us the social information that what the people feel like, but more technical information like the state of the weather or state of the economy, we have a lot. We have developed a lot to get those information from such modern data sources, that is be it websites, IoT devices, mobile, computers, social medias, other research articles, or APIs or sensors. Now, then moving on, the what is the value of making decisions that are data driven? First and foremost, that your data is not just made up of bluffs or made up of guesses. Whatever decision you are making, maybe just not just as a big professional, but let's say even as a student, you make a decision of how you are going to make your group project or how you are going to study. If you use the data that you have previously worked with or used, if you use that, that improves the accuracy of your decision by a very big margin. Then it also enhances your objectivity. And how it does that? That the goal or the aim, your eventual objective for whatever task you're doing, whatever task you're performing, that is enhanced a lot because the date because you're using data, using real-time information, real-time facts to set your goal or set your objective. And these are the key benefits of data-driven decisions. Obviously, accuracy, given that you have applied the right data cleaning methods, data exploration, and data analytics techniques. Then objectivity increases, the predictability also increases. If you are able to analyze the data that is for the activities from the past, and if the data is accurate and your data analysis is accurate, then you can also make predictions that will be much more likely to happen as compared to any other predictions that are not based on data or facts. Then accountability also increases because you can be accountable for the decision that you have made, the data analysis, because that given that you have gathered your data from reliable sources and from reliable people, so that increases your accountability. You can stand your ground and say the decision made is correct because it is rooted in this particular data. Then data driven decision also continuously improve. You might have heard that this kind of thought process is old school, or this data is old school. But since you are continuously updating your data, continuously analyzing that updated data, So the decision that you make will be continuously improved and will be always up to date. Now let's move on to another interesting topic, and this is what we call the types of data analytics. The four main types are descriptive, diagnostic, predictive, and prescriptive. Although these four are quite easy to understand based on just those words, if you understand what descriptive is, what diagnostic is, predictive, prescriptive, you'll also be very easily able to understand what the analytics do. So let's start with descriptive. So as the word descriptive comes from describe. So our goal is to describe the data, summarize the past data, to explain what happened. So again, the word what is a keyword here. With descriptive analysis, we are trying to tell or trying to find out what has happened to answer the one main question, that is what. And the examples can be the total sales or the average revenue or the count of the customers. Now, on the bottom of your screen, you see some of the highly used and very important descriptive analytics tools, and they are Excel, Power BI, Tableau. These are highly used in the industry today for descriptive analytics. Moving on to diagnostic analytics. Here, the main question changes from what to why. The objective is to understand why something has happened or why some trend has occurred. Now, you see again the word diagnostic comes from diagnosis. So, diagnosis basically, you must have heard the word diagnosis mostly in hospitals or among medical professionals because they are trying to diagnose or trying to understand why somebody is sick or why some kind of sickness has happened, maybe through fungus or virus or bacteria. The answers could be anything. Then the approach behind diagnostic analysis to understand why something has happened, to identify the causes behind any data changes or any data occurrences. Now, the further drill down techniques or further techniques in diagnostic analysis are root cause analysis, correlation analysis, and drill down analysis. We'll learn more about them as we go forward. But SQL, Python, and R, these are three important languages that are used for diagnostic analytics. Oh, I have accidentally written descriptive analytics here, but these tools are diagnostic analytics tools. Going forward to predictive analytics. Now, the keyword again here is what, but this is what not for what has happened, but what might happen. We are again answering what, but in a different context. Predictive comes from prediction. So we are trying to find out what might happen in the future or what might happen next. So the method is to use historical data, what has happened till now, and based on those changes, based on the trends, to find out what can happen in the future and forecast the outcomes. Again, the techniques used for predictive analysis are regression analysis, time series forecasting, and machine learning. SAS, Python, and R are good predictive analytics tools. Then we move on to prescriptive. So, see, we have found out what has happened, or why something has happened, or what can happen in the future. Now, our goal is to find out what action we should take. And to find out what action we should take, maybe for company, for your own good, for your own personal household, we find out what action we should take based on prescriptive analysis. And prescriptive, as the word prescription, as a doctor might give you a prescription or a pharmacist might give you a prescription, they're trying to tell you what to do. Take these medicines or perform these tests. So prescriptive analytics helps us find out what, after studying everything, what we should do. And the techniques are optimization algorithm, decision trees, and simulation models. And then Gurobi and Excel Solver are some very important prescriptive analytics tools. So I hope you all are clear on the four main types of analytics. And you should be clear because we are going to enter into another activity, another fun quiz. You will be given scenarios and you guys will have to tell what type of analytics should we perform. I hope you guys are ready. Let's start with the first one. So recommending the right price for a product based on demand. So shoot in your answer. What type of analytics do you guys think this is? Now if I have to give you a hint, focus on this first word, that is recommend. This will help you understand what the right answer would be. So recommend is a word that is the key here. Recommending the right price for a product based on demand. What do you guys think the right answer is? All right. If somebody has raised a hand, two participants have raised their hands. And there's 7 participants. So are you guys not able to type? Is such an issue? And can you please look into this? Why they are not able to type? And or Tanuja, if anybody is here, they are not able to type in the chat.
Karthik, it's been enabled.
Okay.
Yeah.
Okay, so now I'm getting all the answers. So I see answers like predictive, descriptive, prescriptive, again predictive. So guys, focus on the word recommending. Recommending is to do what? To provide a suggestion or recommend something or to prescribe something. So a majority of you are correct. So I have received a lot of answers saying prescriptive, but a lot of you are also saying descriptive and predictive. So guys, this would be classified as prescriptive because as I said, the keyword here is recommend, and recommendations is like we are prescribing what to do, and this type of analysis is called prescriptive analysis. So good job everyone. Most of you are saying prescriptive. So moving on, let's see one more. So forecasting the weather for the next week. So what are your guesses for this? I see descriptive, I see predictive, predictive. All right, so majority of the answers are predictive. So guys, I guess you all looked at the keyword that is to forecast and to make your predictions or forecasting for the future. They will be classified. So Harshit Rawat has written Bhavishyavani. Nice, Harshit. It can be called Bhavishyavani. Predictive. So yeah, you all will be correct. This will be classified as predictive. So moving on to the next one. So identifying why sales decreased in a certain month. Now again, just to give you a hint, why is the keyword here. So what are your guesses for this? So very quick. Very good. So I see a few answers of descriptive. Right. Otherwise, most of them are either diagnostic and a few are descriptive. So guys, if you remember, why is the keyword, and whenever through analytics we are trying to understand why something has happened, like in this case, we are identifying why sales decreased over a period of month. So this is this diagnostic analytics. So Vishal, Shruti, Aviral, Drashti, Yarsha. So you guys are all correct. Good job. So HP says, please repeat diagnostic analysis. So the key word for diagnostic analysis is the word why, guys. So why is whenever we are trying to find out why something has happened, like why, uh, let's say why the temperature, the global temperature is increasing, or why the sales for a certain month or a certain company is decreasing. It could be maybe due to the weather, maybe due to the decrease in quality of the product. Whenever we are talking about why something has happened, then we are considering the applications of diagnostic analysis. Yes, Utkarsh, good job. So you are correct. So if you talk about why and how both, so that is a very good understanding. Even when you guys are telling how something has happened, that is also diagnostic analysis. So eventually identifying why sales decreased in a certain one will be categorized as diagnostic analysis. Moving on. So summarizing the total number of units sold by a store. So what are your guesses for this? Ramya says descriptive. Palak Jain says descriptive. Pratik Singh descriptive. Okay, so this might be the only one where there are no wrong answers. Everybody is right. So I guess you guys have a good hold of what descriptive analytics is. So yes, you guys are all correct. This is descriptive. So the word summarizing is key here, or more telling what has happened. That is where descriptive analytics plays a role. So Raghav and Purvi Agarwal are saying, please explain descriptive analytics. So descriptive analytics comes from the word describe, basically trying to understand or describe what the data is, what the data is trying to tell us. Even in this case, the word summarizing or finding the answer to what the data is, what has happened, that is where it is called descriptive analytics. So no predictions for the future, or no recommendations or suggestions, or no finding out why something has happened, just finding out what has happened, what the data is trying to tell us. That is descriptive analytics. And so yes, summarizing the total number of units sold by a store would be descriptive analytics. Moving on, the last question for this. So estimating how many people will visit a website tomorrow, or let's say even you can include offline store here, maybe your offline store. What kind would that be? Okay, Navraj says diagnostic. Yashwant says predictive. Nipun says predictive. Rakshita also predictive. Okay, so lot of the answer, majority of the answers are predictive. Vishal says predictive. Predictive, it will predict how many people. So good answer, Isha Yadav. So all right, so yes, all those people saying, majority of you are saying predictive. Predictive is the right answer. The keyword here is tomorrow. As you can see, we are making a prediction or estimation for something that will happen and has not happened. So as one guy earlier said, don't call it Bhavishyavani, because this is not bluff or guesses. We will be using the predictive analytics to make a decision rooted in facts and data. So Krishan has said predictive 4 times. Yes, Krishan, we hear you. This is predictive data analytics, and you will be correct. All right, so that was it for this quiz. Moving on. Now let's talk a little bit about data visualization. So data visualization uses infographic elements like charts, graphs, maps, or dashboards, and many more other elements to present the raw and complex data in a more graphical manner or easy to look at manner, so that the understanding of the data becomes easier. The goal with data visualization is to make complex data sets and complex data much more easier to understand and interpret. It helps us in identifying patterns that are hidden, trends that are happening, and the outliers very quickly. Then data visualization also supports better and faster decision making, and it turns raw data into a visual format that is more accessible and engaging. So before we go forward, so let's talk about how data analytics is not just shaping industries, but is also shaping the future. be it students or career professionals. So, data analytics is a field that blends numbers with narratives, logics, infographics, with data visualizations, with innovations, with insights, and the impact that it creates. We live in a time when data is more valuable than even oil because every click on your phone, every transaction, every vote, every health report, it is all data. And in a country like ours that is so vast and so dynamic, this data is our biggest untapped resource. Whether it is predicting crop patterns or farmers in Punjab, then managing traffic in Bangalore, or improving healthcare access in Assam, or optimizing supply chains in Mumbai. Data analytics is the backbone of making smarter decisions. Now, what does all of this mean for you? It means that whether you are a student of commerce, engineering, statistics, economics, or even arts, you have a place in the world of data. You can become a data analyst, a business intelligence developer, data engineer, or even a data driven entrepreneur. You can work in startups or global tech companies or government think tanks or NGOs. You can help build a digital India. You can learn tools like Python, SQL, Excel, Power BI, or R. You can also explore concepts like data visualizations, machine learning, and predictive analytics. But more importantly, you will learn to see how patterns where others see noise. You will learn to tell stories that matter with data as your language. India is going digital, and the future belongs to who can read the signals in data. You don't need to be a genius to start. You just need curiosity, consistency, and courage. The courage to upskill, to take that first course, to do that first project, or to build a portfolio that speaks louder than any CV. Remember, the world today needs more people with skills, and data analytics is one of the most important and most in demand skills today, not just in India, but globally. So you can ask yourself, what job can you get? What problems can you solve? Because that is what true data analysts do. They solve problems and they make an impact to shape the future. So all the different elements, be it data visualization, analysis, data cleaning, data transformation, data exploring, they all can make you a very recognized someone who stands out, a data analyst who is highly skilled and stands out as an achiever and can have a big future ahead of themselves. So looking at more elements of data visualization, how you can play with that. So now we'll step into some very easy territory. Now, see, it is not, you guys might already aware of different types of charts or bar charts, pie charts, line charts, or scatter plot. Now we will not look at what different type of charts are. We already know what they are. But a very important thing, a very, very important thing, having the ability to create the most fancy looking dashboard or the most fancy looking chart is not as important as knowing what goes where or what type of visualization is suited best for what type of data. Even if you are highly skilled with tools like Power BI or Tableau, but you lack the knowledge of what tool is the most efficient, what type of data is best for bar chart or line chart, that is where those knowing those skills doesn't come in very handy because the goal with visualization or analytics is to make raw data easier to understand and interpret. But even with your visualization analysis, if you are not using the right tools and techniques, you can still not solve the complexity of data and it can still be a bit hard to understand. So starting with bar chart, the purpose it serves is to compare data across different categories. So make sure whenever you are categorizing data, then bar chart is of best use. The design is very simple. We already know it represents bar, the size of the bar, or more, the height of the bars represent the data, the size of the data, what the magnitude is. And the use case is to compare maybe sales counts or frequency across different groups or categories. Then moving on to line chart. So the keyword or the key metric for line chart is time. You might be comparing data across months, across quarters, across years, across weeks, or even days. Line chart, make sure you use a line chart whenever you are tracking changes or patterns across time intervals to monitor trends. So the design is also very easy to understand. The different data points, they are connected through lines to highlight continuity. So see, highlighting continuity in time is very important because that is how you show the continuous flow of your data. Then the applications, they are used, line charts are used in finance, weather reports, time series data, and a lot more. Moving on to pie chart. The keyword for pie chart is proportions. That is how much a single element or a single data point is comprising of the entire data set. In what proportion a single point exists. That is out of 100%, based on the size of the segment of a pie chart, you can tell how much of the entire data set one single data point has taken. So whenever you have to represent proportions, that is when you use pie charts. The pie chart, very simple. It could be either 2-dimensional or 3-dimensional. It can also be made into a donut chart. So the goal is to convert into slices that shows the proportion of your data. And each slice is used to read to how much percentage a category holds. Then for histogram, so histogram is nothing but a bar chart. But if you guys remember, in quantitative data, we learned about discrete and continuous data. If the data is discrete into straightforward categories, we use a bar chart. And whenever there is range, rather than having straightforward numbers, we have range, we use the same bar chart, join them to each other, and that is called a histogram, because where one range ends, the next one starts. So same data that is used for bar chart, if it is in a range and we don't have discrete data but rather continuous data, then histogram is used. The design idea is same. The height of the bar indicates the magnitude of the data. And use cases, it could be for analyzing data spread across, like could be test scores or any other measurements. Moving on to scatter plot, we have already seen a very good example of scatter plot. We saw in the how the football shooting points were put on a scatter plot, but you also see this image on your screen. The purpose is to, of course, show correlations and the clustering between two numerical variables. The goal is to visualize that each dot represents a certain data point on the y-axis or i-axis, and it is highly used in statistics to detect patterns and outliers. So scatter, as the word says, the scatter plot shows us how much our data is scattered. That is how far out it is from each other. Just to give an example, how you will find out outliers. Let's say you take the ages of everybody in your class, and you find out the average of that. Since majority of you are college students, let's say the average comes out to 20 years. Now, let's say you add the age of your teacher to that data. You find out average again. Turns out the average has now increased. Now, based on that average, you would see that the average might represent data in a wrong manner, because that average, maybe let's say it has jumped to 22 or 22.5. That might show someone who has already graduated from college, or maybe not in his first or second year, but maybe in the final year. So in that particular case, the age of your teacher, who might be 40, 45, or 50 years old, that age becomes the outlier. If you use that data, the data of your age, to plot on a scatter plot, you would see a lot of data points, that is for all you students, would be all collected in that range of 18 to 21, because that is what your age is. and you would see that one data point will be far out. It could be one data point. If you are including more, there are multiple data points. But the scattering shows that this is the main data, and here are the outliers. For further, more efficient data analysis, what is done is outliers are sometimes removed or ignored so that much more efficient data analysis is performed and better decisions are made for the group. Now, moving on, we come to box plot. Box plot is something also used a lot in economics and finance. So it uses these statistical functions. It doesn't use them, but rather it represents the minimum, the maximum, the medians, the mode, the average, or the quartiles succinctly. Now, how this can help, if I have to give you an example, let's say you work for government and your task is to uh, collect the economical data for let's say in Mumbai you are going to collect the economical data of a community in the Dharavi locality. Now let's say within that data you collect data from 1,000 households. You find out the average income comes out to be, let's say, 8,000 rupees. Now, based on the 8,000 rupees average income, you put that into a category and make the government schemes or the government decisions are based on that. But one day you find out that within those 1,000 households, there were, let's say, 100 households who were well above the below poverty line category, and they were from a very well-to-do family. And that those particular data points has skewed our data. So what has happened is the remaining 900, where the average income was less than 5,000, now that data is skewed, and the schemes were not made in a very good manner. And those people who are in the below poverty line category, they are not able to reap the benefits or even being provided the right things, because due to those outliers, the data based on which we have made the decision was changed. Now, in this case, how box plot can help? It can help you. It basically plants on the same grid lines, x-axis and y-axis, is plots boxes and whiskers. So lines are connected to those boxes. So the main type of data is categorized into that box, and all the outliers, their points reflected by a line that connect the main central box to all those boxes. So that main central box can be used to categorized into different types of data, and the outliers can be categorized into different sets of data. And that is how box plot can help us identify the outliers and also the statistical points of that data. And as I have given you example, it is ideal for comparing distributions between groups or variables. Now moving on to heat maps and tree maps. Now these are something that I find very interesting. So what happens a lot of times when data is quite complicated or quite skewed and there are too many data points, what happens is you are not able to plot them into a bar graph or a pie chart or any types of general chart. So what happens? Data is still in table form. Because imagine if you have data from 1,000 cities. Imagine having a bar chart with 1,000 bars. You would rather make that data much more complicated. Same goes with others as well. The complexity of data points can sometimes make it harder for us to create any kind of visualizations. That is where something like heat map comes into play. So for heat map, data stays in the table format itself. But what you can do is you can alter how the data is highlighted. For example, the image that you see on the left of your screen, you would see that even though you might not even be able to read what the text is saying, but if I tell you that as the color goes towards the lighter shades of orange, the data is decreasing, and as it is going towards the darker shades of blue, the data is increasing. So immediately your vision will either go to maybe this what is this, 8th column, 3rd row, because you already know. See, that image is small, even I can't read it properly, but you immediately know. If you want to know about the biggest data point, you have to zoom in to that particular cell. And similarly, if you are someone looking for the lower values, you will go to maybe the 2nd row, 1st column, or the, what is this, 1, 2, 3, 4, 7th row, 5th column. And based on that, even within the raw data format, that is a table format, even if it is hard for us to visualize, you can still use the techniques of heat mapping that can help us understand, or not understand, visualize or present our data in a much more understandable manner. Then the next is tree map. Now, tree maps are used for something where data is still complex, where still there are a lot of data points, but we can resolve it a little bit. So what tree map does is, rather than using the raw table format, it uses a lot of boxes mixed along with color sheets. So what happens in a tree map? We either create, so tree map is actually free of shapes, although I have used rectangles here or squares here. You can use any shape you want, but the size of that particular shape, in this case, the size of this rectangle, shows the magnitude of the data as well as color. So, see, currently we don't know what this data is, what is happening in New Delhi or what is happening in Kanpur or Pune. But what I can tell you looking at this, that the number in New Delhi is the highest, because see, sometimes on first view you are not able to understand, because of the shape, whether the box for New Delhi is bigger or for Mumbai it is bigger. But see, based on the shade of the color, you can easily recognize when New Delhi is a bit darker and the data for New Delhi is the highest. So here it uses both principles of colors as well as size. So the biggest magnitude of data, whatever it may represent, is in New Delhi, and the smallest might be in, that is Indore, I think. So Indore or Kanpur. So small, the lighter colors, the smaller boxes. So small data, bigger boxes, and darker colors show uh, the higher data. So these two are the examples of when data is complex with too many data points, and you still want to visualize them or represent them in a manner that is much easier to understand. Now, moving forward, now as I mentioned this previously as well, we did not look at all those chart types to learn what charts are. We have all, you must have already studied them in, those are very basic charts, right? We have studied them in schools, but more important is your chart selection, considering what your data type is, or defining what your message is. Your data type can be categorical or continuous, or your message could be to compare data or to show trends or the various distribution. Based on that, you can see the categorical data will benefit from bar or pie charts. Continuous data will benefit from line chart or scatter plots. Then similarly, comparisons for bar chart, column chart, trends, line chart or area charts. And distribution happens through histograms or box plots. Now, currently you see on a screen only these many words or numbers, but visualization is open to interpretation and every person's individual creativity. It is not limited to what I am telling you or what you have learned in this class, but more to use your own creativity, learn your own thought process to find out various methods of how you can visualize data, make it easier and efficient to understand. As I said, so this last three, these are my recommendations that you go on your own and study them. So the number of charts and graphs that you can create, they are endless. But radar chart, bubble chart, and waterfall chart, these are some advanced type of data visualization charts that you can use to visualize your data. And these are up for you to explore yourself and understand. But these three are not the only one. If you guys are aware, you can maybe put in your recommendation suggestions so other people can learn from them what kind of different visualization are there. Use the chat for that. Okay, so that was the end of data visualization. So I have found this interesting video from a channel called Column 5 on YouTube. So all credit goes to the channel column 5. This is a very interesting video that shows how beneficial or how good data visualization is. So let's watch this video together.
They say knowledge is power, but how do we make knowledge powerful? Especially when that knowledge comes in the form of data. Lots of data. How do we find the meaning? Tell the story. Share the story. Infographics, where data meets design. What makes good data visualization? Take a few seconds to count the 7s in this number set. How many were there? Not sure? Now try. A simple color change makes comprehension almost instant. Color is one of several pre-attentive attributes, like size, orientation, flicker. Visual clues that the human brain processes within 250 milliseconds. Now imagine that we're not looking for specific numbers, but patterns. We can use color to show correlation, size to show quantity, or orientation to show trends. And not just data. The power of design can be used to better communicate all sorts of information. Processes, hierarchy, anatomy, chronology. Better communication through innovation. Because your message is only as good as your ability to share it.
Alright, guys, so we have reached the end of this session. Thank you very much. My time with you is now done. I really hope you had a great learning experience and also enjoyed through this. Thank you all very much. Now, before I leave, I will hand over this meeting over to Tanuja. So back to you, Tanuja. Thank you very much.
Thank you, Karthik. I hope you've all had a wonderful session, and we'll be closing the session. Before we leave, we'll be sharing an attendance form link. Please make sure that you fill the attendance form by 10 p.m. today. I hope I'm audible. Okay. So yes, I kindly request Milind and my other team members to please share the attendance form link here on the chat and in the WhatsApp groups as well. So please fill the form by 10 p.m. tomorrow, and don't forget to complete your learning plans by 14th July. And we hope to see you in our next masterclass. Thank you so much, everyone. Have a great day. Bye. Thank you, Karthik. Thank you, team.